This is the course introduction for CS332 fall 2021 semester. And by the time we're done with the discussion, you should be able to identify the major themes of the course and identify the way we deliver the course. There's online notes, there's online recorded lectures, there's in-class lectures. State the course deliverable types. We're going to do some assignments, software programs, reports, no in-class exams this semester. Instead, I'm going to reuse what we did when we were online, which is instead of a few small, large payoff assignments, have a lot more smaller ones, each one counting for less. I don't think it will be overwhelming. Identify the course outcomes listed on the syllabus. Understand how your grade is calculated. The assignments give you 320 points. We'll have some software programs for 220 points, and then two really small reports for 60 points, and that's 600 points total. And then your grade is your standard 90%, 80%, 70%, and so on. Okay, what are the major themes here? This is an interesting class because it can be either highly theoretical or highly practical. I've tried to actually split the difference here. So we have some theoretical aspects that underpin all computation and all programming languages, and then some more practical aspects or applied aspects when we talk about the specific major programming paradigms and how to actually produce programs inside of them, produce software. So we start with some formal language theory, language definition, languages and grammars. This sets up the idea of computation and computability. Then we talk about different models of computation, the relationship between the languages and the models, and the idea of what it means for something to be not computable. And then the more applied portion of the course are the programming paradigms, the imperative/procedural, object-oriented, functional, and then you'll do programming exercises in each of those different categories. The course outcomes, I won't read through this list because you can read through it yourself. It's in the syllabus. But these are the specific things that you should be able to achieve by the time you're done with the course. Basic policies. We meet every Monday, Wednesday, Friday at 9:05 in LB 269. I'll have office hours every Monday, Wednesday, and Friday from 11 to noon. That's in my office in LB 356, and also by appointment. So I'm going to be asking people to mask up when they come in my office. If you don't want to, you can always meet me via Zoom. And I can always meet by appointment either in person or via Zoom. We'll have some Canvas discussions, not graded. I'm trying to get interaction, trying to get you guys to think about the topics here. Assignments are all going to be on Canvas, and so we have, like I said, instead of in-class tests that are worth a lot of points, smaller, lower stakes assignments. 5 programming assignments. They're all relatively small. There's no project this semester, and 2 small reports. Our schedule, one of the benefits of the pandemic was reorganization of courses into a more meaningful way, maybe. So everything is broken up into modules, and we start out with languages and grammars, move to models of computation, just deterministic finite autonoma, another model of computation, the push-down autonoma. And then for the first time, I'm going to try introducing non-deterministic models this semester, so that'll be about a week long there. I think there's value since we're living in a distributed and parallel world these days, and things happen in a non-deterministic way more often in a parallel application or a distributed application. And then the last model of computation is the Turing machine. From there, we'll move into functional programming paradigm and spend a fair amount of time on it because it's the one that most people are the least familiar with. And we'll introduce that with lambda calculus, which is the underlying mathematics of the functional programming language. While you're learning lambda calculus, you're actually learning the syntax of the program that we're going to use, the language that we're going to use called Racket. So we'll spend a couple weeks on that. and then move back to the other paradigms that you're more familiar with, the imperative and the object-oriented paradigms. And then finish off with some understanding of how your programs, once written, get turned into executable programs. So spend a few weeks on compilation, lexing, parsing, program analysis, program optimization, and semantic analysis. Semantic, of course, being the meaning, quote, meaning of the program. So we'll talk about syntactic analysis, which is the structure of the program, and semantic analysis, which is the more like the behavior of the program. And that's the course in a nutshell. So I'll see you on Monday, and we'll go over this again and then answer your questions and start into course topics.